What we need to look at now is the physics of heat, so we can understand the physiology which is going to follow. So a little bit on the physics of heat. Heat, of course, is a form of energy. And the heat energy actually resides in the movement of the atoms and molecules which make up the substance which is hot. So if the air is warm, that's because the individual molecules which are in the air are vibrating. As the air cools down, the reason the air appears cooler to us is because the molecules which compose the air are vibrating less vigorously. There is less energy in that molecular vibration. Conversely, if you warm the air up, the reason the air appears warmer to us is because the molecules which make up that air are vibrating more vigorously. The molecules have more heat energy. This is called the kinetic understanding of heat. The kinetic understanding of heat. So if we have an individual water molecule, for example, when the water is relatively cool, the magnitude and the energy involved in the molecular vibration will be relatively small. It'll just be vibrating a little bit. But then as we warm the water up, we put in more heat energy. The individual molecules composing the water will have a greater amount of kinetic energy. They will be vibrating to a greater amount, something like this. And hence the vibrating water molecules will contain more heat energy. So heat is the molecular vibration, or the atomic vibration, of the microparticles composing the individual piece of matter. And this actually explains why heat can be conducted through a conductor of heat. You might remember that some substances are good conductors of heat, such as metals. Other substances, such as wood and plastic, are poorer conductors of heat. But if you think about a strip of metal, for example, think of a strip of copper. Suppose this is a strip of copper here. Then this is made up of individual copper atoms. Much smaller than this, of course, but the individual copper atoms are composing the piece of copper. And when the copper is cold, these atoms will be vibrating quickly or slowly when the copper is cold. When the copper is cold, they will be vibrating slowly. But suppose I'm to warm the copper up and I put a flame under this end of the copper. So there's a gas flame under the copper, heating it up. Now energy from the flame is going to start atomic vibration in the atoms which compose the copper strip. And these are going to start vibrating. So they're going to start vibrating. And as this one vibrates, it's going to bump into the next one. And it's just like if you're walking along and you bump into someone, then they move as well as you. So that one will start vibrating, and that will start this one vibrating, which will start this one vibrating. And I think you can see that the vibration from this one is going to be spread along into that one, and from that one into that one, and from that one into that one. And so the molecular vibration that is put in by this heat here is going to spread all the way along the copper bar. So the heat is going to progress all the way along here. And then if you come and touch that end of the copper bar, copper being a particularly good conductor of heat, well, you're going to burn your fingers. Now, the next thing we need to understand about heat is it can be transferred from one object to another via one of three mechanisms. Now, heat always travels from hot objects to cold objects, never the other way around. It's always the heat that transfers to the cold. And heat can be transferred via conduction, convection and radiation. Conduction, convection and radiation, the three mechanisms of heat transfer, which we now need to try and understand.